All right, I think we can get started. Very good evening, everyone. Thank you for taking a time off to come attend our second workshop for this AY. It'll be on Introduction to Blockchain Development, held by our very own Director of Development, Phil. So without further ado, Phil, take it away, please.
Okay, thank you, Shomesh. And hello, everyone. I'm Phil, your Director of Development, and welcome you all to my workshops, Introduction to Blockchain Developments. So for today's agendas, we will have 6 parts. I will go through them one by one, starting with a recap of what is a blockchain. Then I will dive deeper into theoretical aspect of what is an Ethereum and what Ethereum virtual machine does. Afterward, I will introduce the decentralized applications. Then there will be an interactive demo, and then I will wrap everything up with some of the framework you guys can play with after this. Okay, without further ado, I will start by recapping what is a blockchain. So a blockchain is an immutable distributed digital ledger with built-in securities. So in a blockchain, transactions can contain all kinds of information, not necessarily financials. And it's usually implemented at a chain of data blocks linked together to maintain the integrity of the entire history. So they have the name blockchains. And there are 3 main components of a blockchain. First is a node, that is computer which run the blockchain protocols. Second is a blocks. It's a basic unit data storage. It contains transactions which are grouped together, and then it created after each network consensus event are emitted. Finally, there's a chain. This is an abstract idea. It's actually a cryptographic mechanism that links blocks together, forming a chain of data with chronological orders and verified integrities. So here's an example of a blockchain, a very simple example. We have the hash. So a typical block is block number 11. We got the previous hash, which is the hash of the entire block 10. Then we got a transaction group, which is you guys all know it's maybe a Merkle trees or a Merkle trees of entire transaction histories. So if any of the transactions is modified, the root will be invalid and the entire block will be discarded. So maybe I don't need to talk about this concept again, because hopefully you guys have been tell what a blockchain is from the previous workshops. So the key property of the blockchain is immutable, trustless, and secure. These are the 3 things I think that is most prominent if we treat blockchains as a ledgers. First, immutability. This to ensure no transactions can be modified and the entire history is kept correctly. Then we also need a trustless property, because there's no third party involved and the entire system should be able to run on its own. And finally, it should be secure, so all the user of blockchains can be sure that no one else can impersonate them or do anything malicious with their account. So this key feature of blockchain may imply other features, like if you got a trustless system that is properly decentralized and distributed. So I think after all, blockchains is an incorruptible ledger. So let's wrap up about the basic idea of blockchains. Moving on, many of you may have heard that we got 2 very popular coins, which is Bitcoin and Ethereum. So the developers are particularly interested in Ethereum, and let's find out why. So what is Ethereum? Firstly, Ethereum is a blockchain protocol, and as any other protocols, it has a native currencies, ETH, and it's got a consensus mechanisms, which is proof of works, and it's moving to proof of stakes. And it's also got a storage structures and a protocol that run the digital ledgers. But what makes Ethereum stand out is its ability to run a complete programs. And in fact, it's a Turing complete, meaning the program can execute arbitrary logics given the resource. So this property makes Ethereum enable another type of account, apart from wallet, which is contract account. This account store the code and execute the logic underneath them. And in order to solve the pattern problems, because in case if anyone places a code that contains an infinite loop inside, then the whole system will be slowed down and can move forward to the next blocks. That's why we need to have a gas system that penalties anyone who is using too much resource. So the example figures you can see here is transactions. These transactions, it make up new account, it moves the balance between account, and it moves the whole blockchain to a new state. So after all, Ethereum is distributed state machines, and we'll go into this concept further. So I just told you that Ethereum is a state machine. Then this state machine needs a platform to operate, and it's the Ethereum virtual machines. The role of the Ethereum virtual machines, or for now I will say EVM for short, is like a Bitcoin ledgers. But apart from being a database for the whole network, it also serves other distributed software platforms. And every node that runs the Ethereum protocols run this software. This software contains opcode that perform logics entail inside all the smart contracts deployed on this Ethereum protocols. So the key takeaway is, apart from storing account balance and perform transactions, Ethereum virtual machines enables the ability to create programs that can run any logics to help govern the networks. And this figure represents a high-level overview of the Ethereum virtual machines. So it contains a machine state, data, a set of EVM opcode, which is like your computer's operating system. But all this thing is virtualized, meaning the software platform is isolated, and it can mimic the functions of computers. So an important point to note about this figure is all the machine state here is volatile, and blockchain only record the events that are requested to be written on the blocks. So on Ethereum, we got two types of events. First is on-chain, which is recorded permanently into the blockchains, and secondly is off-chain. This may execute inside the EVM or execute outside the blockchains. And then now let's look closer into an example of EVM instructions. So the EVM execute at the spec machines. The depth is 1024 items. Each item is 256 bit or 32 byte, and this is chosen to be convenient for cryptographic purpose. During the executions, the EVM maintain a transient memories, or a memory that does not persist between transactions. This volatile state machine I told you just now. So every time the code is run, the operations will calculate the gas beforehand inside the EVMs. Then afterward, the code will be executed if all the conditions are met, and all the instructions are fed from these specs. And this is called logics that execute in the EVM are called smart contracts. And these smart contracts do not contain a storage like your typical account, but this smart contracts is actually a set of bytecode, and this is called EVM opcode. So the EVM will execute the bytecode inside the smart contracts, and this is just like your operating system.
Recording in progress.
So do you guys have any questions about the Ethereum virtual machines? So basically, it's a platform to run the code inside all the contracts, and the contract is deployed on the network. It's like a giant cloud storage, but it's not centralized. Okay, so having the EVMs now we can develop what called decentralized applications, or DApp for short. So what is a DApp? A DApps are applications that have multiple instances running on a decentralized networks, and they typically come with a set of smart contracts and a user interface. The user interface is your normal front end in web tools. So the key properties of the app is decentralized, deterministic, isolated, and Turing complete. So two properties that is important for the apps is deterministic, because we want our smart contracts functions irrespective of execution environments. And secondly, it should be isolated. So if a smart contract run into any problems, or if a developer have any bug inside a smart contract, we must make sure that it doesn't bring down the entire system. So having a DApp, there are a few benefits of interacting or using a DApp. Firstly, it has zero downtime, because the network is decentralized, and it's very unlikely you can shut the whole network down. So malicious actors cannot launch a DDoS or anything else to stop your applications. Secondly, the app is private, and all the users using the app don't need to verify their identity if not requested. Secondly, thirdly, the app is resistant to censorships. So no single entity on the network can block user from submitting transactions, deploying apps, or reading data from the blockchains. Then the app is also have absolute data integrity. The data stored on this blockchain is immutable and indisputable. So there's no false transactions or modified data if it's not the owners. Finally, all the code in application is verifiable, and this is coming from the deterministic properties we talk about just now. But along the benefit, there is some drawbacks for the apps. Firstly, there's a complex maintenance process, because one deploy on the blockchains, the smart contract cannot be modified. So there's no bug fix, but you have to deploy another new smart contracts. Or if there's anything go wrong with the apps, then really you cannot fix it. Secondly, there's network congestions. So you guys, if in the blockchain space for a while, may have heard of some of the minting event, like this app, for example. This push the gas price of the whole network to sky high levels, and this make every transaction on the network cannot execute. But and also currently Ethereum is a bit slow. It's only process about 10 to 15 transactions per second. So it's not a very good environment if you want to run all the logics on Ethereum. And thirdly, there is many performance overheads if you running a entire app on Ethereum, because there is communication back and forth between nodes, between your users and the Ethereum clients. And typically, app running fully on the Ethereum is thousands or million times slower than your typical centralized apps. And that's bring me to the last point. Ethereum's app now certainly doesn't actually fully decentralize, because they want user-friendly and developer-friendly solutions to be on top of Ethereum. So most of the time, the user interface is deployed and operating on a centralized service like AWS or Azure from Microsoft. So such service may store keys or sensitive information on the server side, or if there's a malicious actor, they can bring down the whole interface. Okay, so that's the properties of a decentralized applications. And I want to talk a bit about the very first decentralized applications. It's actually come long away before the world of blockchains and Ethereum. So Bitcoin was first proposed in 2009, and Ethereum come a few years after. But the first DApps actually launched in 2001 by this guy, Bram Cohens, and he's developed the BitTorrent protocols. So this protocol is a peer-to-peer file sharing systems. And if you want to download a file with BitTorrents, it's work like your Ethereum nowadays. You have open a web, you click on the links, and you have to request the file from another computer that running the BitTorrent protocols. But this finally failed because they lack of business models, and they cannot make money or know how to operate the whole system. So there's some notable remark for this DApps. It's laid ground for the first decentralized storage protocols. And now we have many of them, like a very popular one is IPFS. And it has many controversies over usage of these protocols. So I think this is the same problem for Ethereum. So most of the thing is copyrighted, it's being shared, and there's here and there they are stealing each other's. And they finally got acquired by Tron Foundations, and their CEO is Justin Sun. Some of you guys may have seen him on Twitter. So this guy acquired BitTorrent on 2018, and he modify the app to become a bigger part of Tron blockchains. Now it have two tokens. First is a BTTO. It's actually deprecated, and this one is BTT News. So that's the very first decentralized applications. Now I want to talk about decentralized app on Ethereum in particular. So this is an overview of an applications on Ethereum. This is an architecture overview. So we have users, they interacting with the wallet software like MetaMask, and they interacting with the web interface. Then this wallet software will then call the blockchain service providers, and the backend or the blockchain service provider will directly talk with the Ethereum nodes and running the Ethereum protocols. So there is extra two components apart from your typical website, and there will be more communication back and forth. And look a bit deeper into the back end. We got a set of smart contracts, and typically there's two kinds of smart contracts. Firstly is a token smart contracts. It may contain the logics of the token running the networks or your applications. And finally, there's application smart contracts. This thing is specific to each applications. So there are 5 levels in the Ethereal Specs. Firstly is the Evm, then the smart contracts. And running on top of the smart contracts is the public node or the infrastructure providers. So there's Ethereum node, and then we got the client API or the wallet software. And finally, we got end user applications. So this is an overview of applications. A bit dive in deeper. So firstly, we got EVMs and Ethereum blockchains. Then we got the smart contract running on top of it. Then there's a typical front end, then the browser. So to connect the front end and the blockchains, we got the service providers. And if there's transactions happen on the blockchains or any need for authentications, we have MetaMask. So the signer will interact with the front end, then post request to the blockchains. Then if there's a need for decentralized storage, we have IPFS or Swarm. But this 6 components typically make up entire decentralized applications. But if you require more need for performance or UX, then there is 2 extra components. Firstly is the graph. So this is to query the blockchains. You can use this MetaMask, Infuras, or Alchemy, whatever libraries, then to talk and commute with the smart contract. But if you deploy a smart contract, then this thing later need to so you can use Web3 libraries to query and listen for smart contract event, and you can listen to specific event or call back every time an event is used. But there's some limitations. If you deploy a smart contract and later realize you need an event that didn't originally included, so you have to deploy a new smart contract with the event and data. And using callback to handle various UI logics may get very handy, and as your application becomes slow and complex. So there's come the need for the graph. This is an off-chain indexing solutions. So you can actually request for on-chain data, but it's an off-chain manner, so your application is running very fast. And it's you GraphQL as a query language. So this have very low latencies and very friendly interface for developers. And finally, if you want your app to become faster, then you probably need to scale it outside Ethereum, and this comes to layer 2 scaling solutions. And there's a few here. Okay, so let's revisit the Ethereal specs. We got 5 levels. So at the lowest one, the Evm, will be working with the Solidity compilers and the Ethereum protocol itself. In the second levels, working with the smart contracts, we'll use some of the library listed here. Then at the third levels, we'll use the service provided by some of the famous service providers. Then we got the client API. Finally, the end user applications. We'll use mostly JS libraries to communicate with the service provider. Then there's additional spec for storage on the decentralized storage IPFS one. Then there's a service for data querying on chains, and I just tell you just now is the graph. Then there is a layer 2 scaling. So these major projects on Ethereum ecosystem. So we got infrastructure DeFi, data and oracles. So these are the infrastructures. They are providing service to communicate and working with the Ethereum blockchains. And we got NFC and gaming. Then we got some of the bridge to other blockchains. So you can talk between the Ethereums and other blockchains. Okay, so that's an overview of Ethereum and what is the decentralized applications. Now it's time to interact with one ourselves. So firstly, we'll go through some setup. Firstly, we'll need MetaMask, and then we'll set up the remix ID. So okay, first step is to create your MetaMask account. This will be a few minutes. So I have myself a new browser here. So in order to work with MetaMask, you guys typically need to be running on Chrome's, Firefox, Brave, So go to Chrome MetaMask, and okay, you just click add this extension into your Chrome account. This will be a few seconds. Then afterward, okay, if you guys have this Q box pop up here, you guys have successfully installed MetaMask extensions and can click get started and agree. So if you already have a wallet, then it's good. You guys can press forward right now. If you guys don't have, then just create a new one. Key in the password. Then okay, it's creating. So this video is about your recovery phase. I believe the last workshop you guys have already have an introduction about how to create a MetaMask, so I will skip this, and I will remind later also. So I already got myself a new account, and right now I already got the mainnet. So next step is to add networks. So that brings us to the second step. So have everyone create the MetaMask account. I'll wait maybe 15 seconds. If there's any questions. So this, okay. Then it's time to get some test emails. So you guys can visit this link here. Type it into the chat box. The domain name is a bit weird, but it's very convenient to add your. So okay. And I will search for link. Then after connect, okay, I'm not sure why the link is not working. This never mind. Let's do this ourselves. So we got link be or the so Spain to link. Okay. So I have to manually add the link into my account because there is some problems with the website. I'm not sure why. Okay. Okay. I have successfully added Drinkable network to my MetaMask. Great. And next step is to get some test ether to prepare for the challenge. So if you guys head to this link, okay. One. And then you guys can paste your wallet and request 0.1 test ethers. Afterward, you just send the ethers into your account in half a minute. Okay, and then we can head over to the ether nodes and start exploring. So for now, so this is the process. And the address. Okay, so if you head to the links, click, then this means you already got some test ethers. Okay, this should be good. So if you click and you copy your wallet from here, paste into this field, and click send ethers, and you get 0.1 details on this Ricoby testnet. So you're good to go. Then let's head over to Ether now. And it will prompt you to connect your wallet. Great. Then you guys can either click level 0 or click right now. And you guys can go through the instructions. So in here, I have 5 minutes for you guys to figure out everything yourself before we keep going. But do you guys have any questions? If no, then I just keep going. Okay, I guess there's no questions. Then we use the time to read through this. So this set up the MetaMask, your browser console. You can click this by F12, then I prefer double to the buttons. And open the consoles. Type in player. You get your player, which is your address, and you can type it. Here. You can show the address. Okay. This all for instructions. To interact with the contracts, I can click get new instant here. So wait for a while. I cannot see. The contract is already get, and we can see the UI is rendered differently. So if you contracts, there will be information about the contract when you get from either now data. There's a lot of things to take note. But to complete this test level and to make sure we know what we are working on, you can try the instructions. It should be very fast. So you find the info one. Okay, so info nums. Okay. Running. Properties info num, how the numbers, so the next method to put. So this is the return word, so this is the data, and we got 42, so there should be something info 42 here. Yeah. And the method name is the method name. And if you know the password, submit into authenticate. So where should we get the password? Okay, so there's some argument in the authenticate, and if you guys play around, you will know what is the password. So the method name. Okay. And okay, it should be either non-zero. Yes. So that a bit on how to get a contract from Ethernodes and what to expect from Ethernodes. And when we know how to write the contracts, we can move on to our quest, which is level 1. So I have a window open here already, and this is level 1. So this is a smart contract, a simple one, implementing a storage. So it's got a contribution array of address and numbers. So this stores the contributions of each address, and it's got the owners. And it's implementing a pullback functions here, the receive functions. So this is my account. Pullbacks. Get new instance. And this one will prompt me to have a new instance of the contract. And if I click F12, we already got a contract here. And, you can see there's an ABI for contracts. And the API names all the functions we got here. Okay, so far so good. Then the next step is to go through the contracts. So earlier I just said something very briefly about the contract, so we'll go to it on line by line. The first line is the compiler versions. The second is a library import. And, next, we or the constructors. So this thing will create the contract, and as you can see here, the contracts store the. So when the contract created, it sets the owner to the mesh vendors, which is the one who created this contract, and sets his contribution to 1,000 euros. And this modifiers to mark that who is the contract's owners. So secondly, there's the smart contract logics. So it's got a contribute functions. You can read my comment here. Then there's a get contribution method. Return the contributions of the address, which is the callers. Then there's a withdraw functions and the fallbacks functions with this logics inside. So the requires it means the condition inside the bracket need to be met before all the functions could continue. Okay. So it is now toward that we have two objectives to care about. Firstly, we need to claim the contract ownerships, and we need to withdraw all from the contracts. So to claim the contract ownerships, we got two methods. Firstly, you guys can see the code. If you want to claim the contract ownerships, you guys can contribute greater than the current owners, which is 1,000 euros, and that's quite a lot. But there's a second way. You can trigger the receive functions, and this is the receive functions. So the condition here is the value need to be sent greater than 0. Then we need to contribute something to the contracts. And obviously we cannot go by the first method because we no way can get more than 1,000 euros. So we will follow the second way. And there's 4 steps. Firstly, we will contribute a small amount of ether to the contract. So if we contribute a small amount of ether to the contract, and this is less than 10 to the power of -3 ethers, then we will have some contribution register. So this one, we will register some contributions. Then we send a small amount of ether to the contract. If we send a small amount of ether to the contract, the receive function will be triggered, and there's a require here. Since we already send some amount ethers to the contribution method, so this second condition is passed. And if we send some value greater than 0, then the whole require is passed, and we will become the owner of this contract. So we will set up the remix ID to do so. Okay, so to set up the remix ID, this is the code that I can just select all and copy into here. But make sure to add a small field for the versions of OpenZeppelins, and go to the third tab and select the compiler versions anywhere between 0.6.0 and 0.6.12, because we have compiler versions of 0.6 here. So it's actually equal to 0.6.x. Okay. And if you do so, you should be able to compile the contracts. And for sure, why may MetaMask on the second side. Doesn't work, so I'm just using this new account. So since I already got the contract, I follow the step. I go to page. Then go to the IDEs. Then I have all the code here. So I will done all the steps. I just tell you guys this. So in the contracts, have a new file. Go back also. Then copy everything here. Make sure to add 3.4 or 3.0. Otherwise, if you click, okay, select the compiler versions. Then click compile. It will not work because the latest versions of OpenZeppelin actually remove this, because since version 0.8, the safe mark is already built in. Okay, and this will be compiled. And afterward, we can interact with our smart contracts in the remix IDE. So select the forward smart contracts. This have a few core address, and you call our contract listed here. You can see there's a address field. Address. Equal address. Okay, cool. And copy the address. Fix. And we'll have an instead of the contract. So, okay, this is the MetaMask. If you click your address and you see the contributions of your account, you should receive a number 0 because we haven't contributed any to this smart contracts. So what we have done just now, we copy all the Solidity code from these examples. Then we combine it with remix IDEs. Then if we combine the smart contracts, we got a bytecode and an API code. So this remix IDE is in entirely different types. But since we got the bytecode and the APIs, we just need the address, which is here. We just get from the console to work with this smart contract. So get contributions is 0. Okay, sorry. You have to select this also to make sure the remix IDE is working with your MetaMask account. Okay, so get the contract name. You should get contributions, which is 0. Good. Then we have to contribute something, and you can see a 4 different units here. So this is 10 to the power of -9 ethers, and we will contribute. So to get more info on what this unit means, you guys can go for it. And, so there's a convert. So if you guys convert 1 users, you guys have 18 zeros and 9 zeros. very small amount. You just have to plan. You just need to contribute. And since it's a transaction on the blockchains, every time you interact with the smart contracts, MetaMask will prompt you to accept the transactions. So you need to sign it. So sign. And wait for a while. Okay, so contribution successful. If you click contributions, you get the number you just put in here. And if you head to this console, you can code the method now. Get contributions. Again, this time we see a non-zero values, which is our value of contributions. So this verifies that we just interact with the contracts. So next step is to send some value of ethers to trigger these fallback functions. So the fallback functions here will be triggered if we contribute something and we send something greater than 0. And this is the remix IDE. In order to send some raw ethers to the contracts, we don't have any method here because it's called low-level interactions. So previously I worked Googling this issue, and I believe, yeah, in the remix IDE docs, we can find that if we want to send some ethers, we can put nothings in the code data views and input the values. So let's see, very simple. Click trees and we click transacts. This should prompt us to send some amount of ethers to the smart contract, and we will send. Okay. There should be no errors. So what happens if I send nothing to the smart contracts and I just want to, let's say, drain my wallet by paying gas? Then if I click this, then the remix ID will give us some warnings because we don't actually send anything, and this just causes gas, but make no purpose. So it's very friendly. And now if we click the owners, can verify that this is my address. So okay. Players, this address, and this address we just got. So it's actually the same. So we already become the owners, and we can double check it by owner mesh. And we have successfully become the owners of this contract by exploiting the fallback functions. So there is a very big security hole in this smart contract. And our second task, I guess, is to drain the balance of this smart contract to 0. So just head over here, click withdraw. So if we withdraw, then the balance of the smart contract should be 0. And we have no way to verify that, but you can just double check by submit this. So for a while. Okay. This might take a while for now for verify our progress, but since we already do everything according to the instructions, so we got a well done message. So we successfully complete the levels. Does anyone have any questions about this? So there's some remark about the example we just do. First is the Solidity compilers. They have different versions, and they compile the Solidity code into a bytecode. And these opcode are stable unless a hard fork occurs. And a hard fork is ready to occur, which is the merge you guys might have heard in the news. And secondly, the smart contract code need to be future-proof. So just now we see an example of a very poorly implemented smart contracts, and we can exploit the logics to get the ownerships and print everything from the smart contracts. And thirdly, there's many ways to interact with smart contracts. We just need the API and the address of smart contracts, and then we can use any client or public node to interact with smart contract. So the two methods I just show is either using the Ethernow consoles, which I believe already implement a client first, or we can using the remix IDE. So just a brief overview of what is smart contracts and how to interact with smart contracts. But to make any apps, you actually need to work with all the front end, the back end, and the smart contracts. So there's a few tools for you to kickstart your development journey. Firstly is Remix IDE, a very convenient tool, and this officially supported by Ethereum. Secondly, we got this scaffold. So if we head over to scaffold, this is the GitHub repos. You can see the project is actively maintained, and there's a lot of instructions and a very comprehensive documentation for it. So there's challenge that to give, and there's a branch for you to start on. You can either work with DeFi, NFT, or infrastructure. So they have instructions for starting the reports. They have some advice on what to do when you deploy the code, and they have the example code also. So it's very convenient to work with. And there's a big time for Ethereum, so there's a bit about the upcoming merge, and that might have some impact on developers. But if we are working with the application, then there's mostly no impact, because the few chain I note here is actually happen at the low level. So the end application should experience no change, and all the balance, all the data from the past should be migrated to the new proof of stake chain correctly. So thank you for coming to the workshops, and I will link here some reference and further research for you to explore after this. Yeah. Thank you.
Yeah, thank you so much, Phil, for that workshop. I think I understand it's quite a lot to digest, so don't worry, guys. The recording as well as the slides will be shared with you also. You all can follow through along your own time, own target. So there's definitely nothing to worry about. And this is just an introductory course. Of course, there's many more things to learn along the way, and we as a club will be helping you along the way by hosting various workshops. So I would like to thank everyone once again for coming down for this workshop. And before we end off, may I just request everyone to turn on their cameras for a quick photo taking session. So please turn on your cameras, everybody. Thank you very much. All right, give you guys a couple more seconds to turn your cameras on, and then we can just do a quick snap.
All right, everyone look at the camera. Smile. Okay, that'll be all. All right, thank you guys.
All right, thank you everyone for that. And thanks for attending our workshop. I think that's it for today. If you have any questions, feel free to just ask in the group. Yeah. Thank you everybody, and see you next time.
Thank you.